At the boundary where Earth's atmosphere meets space, an ethereal glow holds clues to how weather on our planet interacts with weather in space. To investigate, NASA's new Atmospheric Waves Experiment, or AW mission, is studying waves passing through these colorful bands of light known as airglow. The waves occur naturally when dramatic weather events such as thunderstorms, hurricanes, and tornadoes push pockets of air upward before gravity pulls the air back down. These ripples in the air are called atmospheric gravity waves. Though these waves are normally invisible to the human eye, they can often be seen as distinct patterns in clouds. As atmospheric gravity waves travel upward, they can grow and reach all the way to near-Earth space. There, they contribute to space weather, an exchange of energy between the Sun and Earth that can disrupt satellites along with navigation and communication signals that travel through this region. Attached to the International Space Station, all can observe these waves around the world by recording fluctuations in the brightness of airglow as waves pass through it. By taking one image every second as it orbits Earth, all will provide the first global measurements of atmospheric gravity waves, revealing where and when they occur, how they travel and transfer energy, and how they vary from season to season or across the globe. Little is known about the distribution and effects of atmospheric gravity waves, but through NASA's AW mission, scientists hope to understand more about how Earth's weather can impact the space environment.